Hey, I'm from Earth Science Department. I didn't put my name on because it doesn't matter. Sorry. Okay, some of my colleagues work in the Department of Earth and Planetary Sciences, some in Earth and Environmental Sciences. The discipline as a whole work with everything from origin of life, origin of solar system, to forecasting the climate change. So what Earth might look like in not just 2100, but 100 million years from now. So we move plates, we worry about the core formation. All right, sorry about that, everything. So when you think about 3 V's of big data, some of my colleagues worry about volume and velocity. I'm going to be addressing my colleagues and myself who are dealing with variety part. So in the last 2 years, we had 2 huge number of EarthCube end user workshops. And in 2 of them, sedimentary geology and paleogeoscience groups, with whole participation of about 100 people, identified 244 databases that we access. And those are databases we know about. There are many more data that are just sitting on people's computer, some of them becoming unreadable. Okay, so BrownDog can help us with 244 databases we know about. Trying to get people to upload data into databases, that's our disciplinary problem. Okay, so I'm just going to very quickly go through the variety of data we have to deal with. So since I'm just writing a paper right now, I decided to use that as an example. So Lake Manitoba is in Canada, and my data uses osteocoustic biology, so there are digital images, and the shells are carbonate that can be analyzed. Okay, so it was part of a multidisciplinary project that everybody did their own thing and tried to bring stuff together, sampling scheme, analytical scheme. None of those were coordinated. Okay, and then there was the background data we need. Okay, so the kind of data we have, generally flat files, Excel others, some are photographs, some are hand-drawn, some are field notes that haven't been digitized, no metadata. Okay, so all the things that you hear about long tail, it's here. Okay, and then because a lot of data are not database, you have to follow through personal contact and beg for data. And sometimes they have to figure out how to read something that cannot be read anymore. Okay, so, and then because my shell data said, okay, there are different water sources coming into Lake Manitoba, I had to figure out where the water was coming from. That meant going through all the old agency data of well water data, et cetera, to find out if there were different types of water coming into Lake Manitoba. And then on top of that, because it was ice sheet covered, okay, Lake Manitoba only became Lake Manitoba about 8,000 years ago, 7,000 years ago. Until then it was under ice, and as ice melted, the crustal rebound occurred so that the baseline for Lake Manitoba north to south changed. Okay, so north and south basin of the lakes weren't even connected until probably about 2,000 years ago. So as I'm trying to reconstruct how the lake level in Lake Manitoba changed, how that may relate to climate change, I'm also worrying about change in geodesy. Okay, so you can just see, and then 2 basins that are separated by very shallow sill. Okay, and lake itself is quite shallow. So we have field data, some are digitized, some are not. Instrument data, a lot of them come from proprietary instruments. Okay, so they have to convert it into form that can be imported into Excel or whatever. We have images now, scanning XRFs, X-radiograph images, grain size, density, loss and ignition, magnetometer data. Okay, some of those in MAGIC database. Okay, and mass spectrometer, you have raw data, and then standardized data, and the chronology. My God, you have raw carbon-14 data, and because carbon-14 chronology is not calendar ages, it has to be calibrated, and calibration is being updated all the time. So what has to be in the database is the raw data plus different versions. Okay, so you can just imagine the variety we're dealing with, and lots of data probably disappearing before we can get our hands on it. I think that's it. Thank you.